Hey, g'day guys. This is part 2 of diagnostic connectors and Failsafe. So this time we're going to look at Failsafe. Because a lot of people use the word, they use the word limp mode. It's in limp mode without a full understanding of what limp mode is. And this doesn't just apply to 1UZs, it applies to a lot of cars. And the information that I'll pass on here will apply really well to the Toyota series because Toyota engineers thought the same across the model ranges. The particular one I'm going to talk about is one where it just starts and stops. Now the last video I actually got through without starting the engine at all, which is pretty good for me, isn't it? Not revving the crap out of it. This one's all powered up. It's not running on the JDM ECU, it's running on the US ECU. It's still got lots of diagnostic connectors, it's got an OBD1, it's got OBD2, but it'll all work. It's powered up. Not a bad start considering everything I've been just abusing it with multiple different ECUs and different stuff sprayed up the intake. So that was the first start of the morning. Once it's up and running and in place, it's going to start a heap better than that. So we know this engine runs. However, in a moment I will take my screwdriver and make it so it won't start. I'm going to put it into Failsafe. So if we do a really quick search on Google, Failsafe, or limp mode, I'll put it in limp mode. I've done a Google search here for limp mode. Let's have a look at what it says. Also known as limp home mode, limp home is a security feature in cars which activates when the engine or transmission control unit picks up a fault. Once it detects a problem, limp mode will cause the less important parts of the car, such as air conditioning, to switch off and the speed of the car will be reduced. Okay, yeah, I wouldn't completely agree with that. Here's another one. What causes limp mode? Fail code conditions, or limp mode, occur when there is a problem with the logic of a vehicle's computer. As long as the computer is receiving signals from the map, TPS, vehicle speed, and other sensors that fall within their normal ranges based on the current conditions, the transmission will operate normally. I'd say that's probably from a transmission repair place. And here, actually, this is really interesting. How do you fix a car in limp mode? Shut off the engine and restart vehicle. Fix wiring issues. Diagnose and reset limp mode. Connect an OBD2 scanner. Start scan. Clear the codes. That's okay. And it all kind of does apply. So what is limp mode or failsafe? Well, it could just be a generic default condition that occurs when something goes wrong. So for example, if the ECU doesn't have an engine temperature sensor input, it'll make up a number that will be good enough to get you home. So those are the ideal ones and that's the intention. Limp home, or to get you home. Enough to keep the engine running so you can get home and get it repaired. Hopefully it throws a check light, but I'll show you some conditions where it won't. The other one are some preset operations within the ECU that will happen when certain faults occur. We're going to talk about one of those soon, but let's have a look at the list. So I have here terminals of the ECU. This happens to be for a 96 LS400, which matches the ECU that I'm using. I've got diagnostic trouble codes. We'll have a look here. I have the diagnostic trouble code chart. So this has flash codes and the OBD2 codes. Now, if we have here, you can see here, it's got MIL, malfunction indicator light. I often call them a check engine light, and memory. So this says if it throws a fault code. So we're looking for one in here. If they've got a circle, they'll throw a check code. They'll throw a malfunction indicator light. We get right down here. Look at this one. No. P1300 fuel pump relay ECU circuit malfunction. So if that circuit malfunctions, it will not bring on the engine light, but it does put a code into the memory. That isn't the most troubling of this. We've got down here, starter signal circuit malfunction. Not so much of a problem, but this one, crankshaft position sensor circuit malfunction during engine running. It won't bring on a check light. The engineers thought that we don't need to bring a check light on when your crankshaft position sensor malfunctions under some conditions. It's the way they did it. It seems a little bit strange. Another one for the Aussie guys, your VE Commodore. I think they've got about 60 conditions that will cause a fault code, but only something like 36 of them or something. No, not all of them bring on an engine check light. One of them is the airflow meter isn't plugged in or isn't attached. Doesn't bring on a fault code. Moving on here, I have got here the Failsafe chart. And these are each of the faults that occur, each of the things that occur when certain faults are detected. And this is on an OBD2 US domestic market. Probably applies to the UK ones. These are the codes, these are the functions that are put in. And they're more sophisticated than the early ones, but some of them do cross over. Let's have a look here. P0100. We look over here. Well, let's see what that code is. P0100, air mass flow circuit. And what will happen? Ignition timing fixed at 5 degrees before TDC. So you're going to have no power. Injection timed fixed. One of them is fixed on the CTP switch on. 7 milliseconds of fuel. 7. Considering it needs about 2.5 to idle nicely, it's going to run rich. So you're going to have, if your airflow meter faults, no power because the timing's locked, and lots of fuel. Rich as rich can be. We go down here. Actually, and it's also got fail-safe deactivation conditions. Return to normal condition. So if it stops faulting, it'll go back to normal. If we look on the trouble codes, it'll bring on a check light and it'll be stored in memory. We're going to go down a little bit. Here, this one. P1305. Let's have a look at P03. Did I say 325? p1305. Knock sensor 1 circuit malfunction. Now the other one's going to be p1330, knock sensor 2, isn't it? Back to the failsafe chart, it is. And what will happen in failsafe is you'll get max timing retardation. You're going to have no power. It's going to reduce your power if you don't have your knock sensors operating correctly. Deactivation, switch ignition off. I think that stops the car from running when it's switched off, so there's no more fault. You probably should repair that condition because it's not going to make the power that it should. Now this one is really interesting. This one, p0500. p0500, and I like p0500. Vehicle speed sensor malfunction. The fail-safe condition is, and for you guys that want to get rid of your high speed fuel cut, your speed cut, high RPM fuel cut is prohibited. High fuel speed cut is prohibited. And the idle speed control is prohibited as well. So it turns the idle speed control off. So if you've got a speed fault, when you've wired these up, you may end up with high idle speed if that speed fault is present. High idle speeds, conversions, common, because they haven't been sorted out properly. But you lose your high speed cut. Way back with VVTIs, a lot of them are prone to a high speed cut. So we just used to put the rear speed sensor into a switch. You'd get to 130 k's an hour on a closed road, not on the open road. Speed limit in New Zealand's 100. And you flick the switch, check light would come on, you could go as fast as you liked. It kept it in top gear, the transmission stayed in the right gear, you're gone. But I've since used that information in collaboration with someone who's far smarter than me on electronics to come up with a solution. So the one of particular interest that I'm going to demonstrate today is p1300 or p1305. The condition will induce a fuel cut, and it says IGF signal is detected for 6 consecutive ignitions. It's probably not detected is what they're probably trying to say. There is a fault with IGF for 6 consecutive ignitions. Now I'm just going to grab this one, and I think at the bottom of this it has another little bit of an explanation. Oh, no, it's not on that one, it's on this wiring. So this one here, engine control, it's got a whole lot about the engine control, but I'm interested in this little bit at the bottom. Diagnosis system. With the diagnosis system, when there is a malfunction in the engine control module signal system, the malfunctioning system is recorded in the memory. The malfunctioning system can be found by recording the code displayed by the malfunction indicator light. Fail-safe system, number 4. When a malfunction has occurred in any system, if there is a possibility of engine trouble being caused by continued control based on the signals from that system, the fail-safe system either controls the system using data, standard values, default values, recorded in the engine control module memory, or else stops the engine. So for Toyota, fail-safe. So for Toyotas of this era, fail-safe is they'll make shit up based on memory in the ECU. Sometimes it'll use the last known condition, or stops the engine. Now that's really, really safe, isn't it? Really safe. Let's demonstrate. So I'm using my phone. We can see here we've got coolant at 11 degrees. So do we see this? We now have 80-degree coolant. The Toyota ECU has just made stuff up. I'm going to plug this EFI temp sensor back in. Okay, it's set to slide on. Got 80 degrees. It's a little hard to see. $11 degrees becomes 80 degrees. So the Toyota ECU, if it doesn't get a signal, it just makes it up to a default value. Try starting a 1UZ with the EFI temp sensor that's totally failed, and it decides on a morning that's 8 or 9 degrees that it's actually 80 degrees. It thinks that the engine's 80 degrees. So it's fueling, it's cold start, it's going to be hard to start. Let's do the intake. I'll unplug the airflow meter. Airflow meter, intake temp of 12. I'm going to be 20. There it is, 20 degrees. So if the air temp sensor fails, the engine will still kind of run okay. But if the water temp sensor fails, it'll be hard to start. But once the engine's actually up to temperature, you're probably not going to know much. It'll run fine. While I was over there working on it, I induced another fault. Let's try start it. I've got a list of faults here. In fact, 14 of them. 14 faults. Airflow meter. Air temp sensor. Will I unplug those? Coolant temp. Will I unplug that? Exhaust gas recirculation. Oh, I need to go through how to solve that for people as well. That's a different video. Solenoid A, B, and E. 1305. And that's the one we're talking about. 1305. So we can see here we've got P1305. We go down here, P1305. So here, P1305, igniter, bank 1 circuit malfunction. And the trouble area is open or short in IGF1 or IGFT1. In the trouble area, it lists open or short in IGF1 or IGT1 circuit from number 1 igniter to ECM. Number 1 igniter or ECM. This actually works perfectly for what I'm trying to demonstrate too. It's told us the problem areas. So people will get a fault code like this and start checking wiring, which is good. Igniter, check the igniter or change igniters. That's good. However, it's not going to fix the problem because the information is good, but it's not 100% correct. And this is where diagnosis can be really tricky if you don't understand what it's actually trying to say. What it's saying is there's a problem in number 2 ignition circuit, IGF2. Number 2 ignition circuit, there is a fault. So to diagnose this, one way would be to flip the igniters around. The plugs are the same, the igniters are the same, so you can just turn them around. So these plugs are the same. And actually on the igniter, what we're talking about here is we've got the pins for the igniter are listed under here. We've got battery input, external, which is the tacho, coil, input, and feedback. So what the ECU's detected is it hasn't got that feedback for 6 ignition cycles, and it's brought on a fault. We can see what it does if we look on the Failsafe chart, code chart, for a p1300 or 1305, is it cuts the fuel. Let's turn the fuel off. This thing's got no fuel. So the other thing that people will find with this particular fault is if they're clever and they can scope the injectors or check the injectors, they'll find the injectors aren't running. So they think it's an ECU fault or a fuel supply fault or something else other than what we're really looking for. I'll do a little bit more diagnosis. Engine start. Let's see if I can do this on my own. It actually sucks my finger in. It's got to be a fuel problem, correct? Here I was, I'm running it on engine start. I'm running it on engine start and it runs. That means it must have spark, mustn't it? Mistake number 2, not understanding what's really going on. And this is why this particular fault can be tricky if you don't have all the information. It was running poorly. And if you've actually watched one of my videos recently, you watched, I had an engine running on 2 cylinders. I used a Sora ECU, and the fail-safe conditions on a Sora ECU are different to an LS400. I wouldn't have been able to do that video on an LS400 ECU. It would have stopped, like this one. It goes into fail-safe. So safe, it turns the engine off. That's super safe. So I've got an engine here that if I hit it on the starter, it just starts and stops. If I feed it engine start, it runs. So how do I diagnose this? And of course, if I'm putting fuel in and it runs, it must have ignition. That's not the case, because Toyota played this trick on you and put fail-safe or limp mode in place that turns the engine off on an LS400 ECU and not a Sora ECU, just to really make it fun. How are we going to diagnose it? How can I show you what I'm talking about? And that gives me a little bit of trouble, because I want to check spark and I want to spray flammable liquid right by where I'm testing spark. And I've got 2 hands. I'm going to do it anyway. We might put some eye protection on. So I go straight over here to number 5 and number 7. The reason I go to number 5 and 7 is number 7 is off this distributor, and number 5 is off that one. Watch for spark. There was spark. Hopefully we saw it. Okay, this time. Watch for spark. There was no spark. So we've got code 1305, which points to ECU wiring or igniter problems and no spark. Now, what did I do so quickly to induce this fault? I unplugged the coil. And it doesn't say anywhere in that list that that would give this fault. But a failed coil can cause that. The information points you on a whole different rabbit hole, on a wild goose chase. The information that you might gather will give you big problems. And this is one of the reasons I see these cars sitting around not running or not diagnosed, because of this fault. Or conversions that have just been wired up and they just haven't pushed the coil connector on properly, or it's got a shitty connector, or the front crank loom connector that goes down to the coils has got corrosion in it. All those things can cause these codes. And it happens on the non-OBD2 as well in the LS400s, but it doesn't always throw a code. But it won't start the engine. It'll just fire and stop, fire and stop, fire and stop. Big helix cause it to start and stop too. It's back to running. This is going back to OBD1. That ECU's going to come up again for some more testing. But I hope that's been helpful. We'll talk to you again soon. Catch you later.